Welcome to this particular module, and in this module we will see the other applications of the operation amplifier. So, what are the other applications of op amp and how we can use that applications, or this particular circuits are used in which kind of other applications. Not only the application of op amps, but the circuits that we form out of the op amp, that circuits are used where, that is also the details that we need to understand. Alright. So, having said that, in the last lecture we have seen not only on the breadboard, we have also used the multisim, right. This lecture or the set of modules, in fact we will show you in both breadboard and multisim, so that you also understand, in case if you do not have the equipment what I am showing it to you right now, you can also perform using the simulation tool, right. The same experiments you can also perform using the simulation tool. So, the point is, you whatever we learn in theory we have to apply, that is the point. Alright. So, if you come back to the screen, what is the today's experiment? The first experiment today is the window detector, and we will see how this window detector can operate. Before we understand the window detector, one thing we need to understand is the comparator. So, we have already seen the role of the comparator. Comparator is nothing but, if I draw op amp, right, I have two inputs and I have one output. If my inverting input is greater than non-inverting input, right, my output will be low or negative saturation. If my inverting input is less than positive or non-inverting terminal, the voltage at non-inverting terminal, then what will I have? My output will be positive saturation. Comparator, it will compare, and compare is like, if I have 1 volt, 1.1 volt, then 1.1 minus 1 is 0.1, and this is because 0.1 is greater than 0.1 is a difference of 1.1 and 1, then we have inverting voltage at inverting terminal, which is more, that is why it will go to the saturation mode, which is positive saturation. This was the understanding about the comparator. Once you understand the comparator, you will easily understand what is the window detector. Now, you see this particular circuit. What is there? There are two operation amplifiers. We named one as A1, we named second amplifier as A2, alright, and then we have resistors, 3 resistors here. So, and we have a load resistor connected to both the output of both the op amps, right, it is connected here, load resistor, and it is we have VCC, we have ground. Now, what we are looking at, if I take the value here, if I take the voltage value here, then it will be 2 by 3 of VCC, correct. We have 2 by 3 of VCC. If I take the value here, it will be nothing but 1 by 3 VCC. So, this much is easy. So, we are applying a 2 by 3 of VCC voltage. Suppose VCC is 10 volt, then 2 by 3 of 10 volts. If VCC is 15 volts, 2 by 3 of 15 volts. Alright. So, that much voltage is constant voltage we are applying to the non-inverting terminal. Here constant voltage we are applying to the inverting terminal, constant voltage to non-inverting, constant voltage to inverting terminal. Two things very easy, Now, what we are looking at further, that the voltage here that we are applying, it is fed to the voltage here as well. You see, the voltage there we are applying to the inverting terminal is fed to the non-inverting terminal here, and here the constant reference voltage is given to the non-inverting terminal, here constant reference voltage is given to the inverting terminal. So, now you understand, if I have 3 resistors, if I have 2 op amps, I have to give the first reference voltage to non-inverting terminal, second reference voltage which is 1 by 3 VCC to the inverting terminal. I have to give a voltage and short the inverting terminal of first op amp with the non-inverting terminal of the second op amp. Extremely easy, right. So, now once you have this configuration, how the circuit will work. So, let us see how the circuit works. A window comparator is basically the inverting and non-inverting comparators. You see, inverting and non-inverting comparators, right. Comparators combine into single comparator stage, they are all integrated. The window comparator detects input voltage levels that are within a specific band or window of voltages. It will measure the voltage which is within the specific band. We will see how, alright. instead of indicating whether a voltage is greater or less than some preset or fixed reference voltage point. Right. So, what is that? Let us see again. The window comparator detects input voltage levels that are within the specific band or window of voltages instead of indicating whether voltage is greater or less than the preset or fixed voltage reference point. Right. So, window comparator will have two reference voltages, we can see reference voltage 1, reference voltage 2 implemented by a pair of voltage comparators, one which triggers an op amp comparator on detection of some upper voltage threshold V reference upper, and one which triggers an op amp comparator on detection of lower voltage threshold V reference lower. We have V reference up, here is V reference up, this is V reference lower. Okay. So, that is what it says, one which triggers, if this has two reference voltages, one which triggers an op amp comparator on detection of some upper threshold voltage, another one detection of lower voltage threshold which is V reference lower. Then the voltage levels between the two of these two upper and lower reference voltages is called the window, all right. So, if you see here, if I have an input signal, you see here was VCC, right. I have this reference 2 by 3 VCC which is my upper reference, I have 1 by 3 VCC which is my lower reference. If I have an input signal as shown here like this, which is a triangular wave, then what I look at, my output is somewhere between my reference voltages, between my upper and lower reference voltages, and that is why I can detect this window, and that is why the signal at the output looks like the window that we are kind of detecting, right. So, we have V output, right, which is only in this region, only in this particular region, and this is because of the comparators integrated in this particular fashion, right, and when we apply input voltages, then correspondingly we will get the output voltage in similar fashion. Now, before we go that, let us see quickly what the circuit is. It has a voltage divider network, we can see that. Where is voltage divider network? Voltage divider network is in front of you, which is your R 1, 2 and 3. 3 resistors are there, R 1, R 2 and R 3, and it is a very simple window comparator circuit as shown here. This is a circuit, hence the voltage drop across each resistor will also be equal to 1/3 of the VCC, right. So, you see if the total is VCC, then across each resistor the voltage drop would be 1/3 of VCC, right. Then in the simple example we can set the upper reference voltage 2 by 3 VCC, that is what we have set 2 by 3 VCC, and the lower reference voltage we have set at 1 by 3 VCC, right. Lower voltage we have set at 1 by 3 VCC. Now, when V in is below the lower voltage level, when V is below the below the lower voltage reference, then which equates to 1 by 3 VCC, which equates to this particular value, the output will be low, when V in exceeds 1 by V3. So, why output will be low? Because you see here, see V in is less than 1 by 3 VCC, right, less than 1 by 3 VCC. So, you have to understand that if I apply voltage here, this one I have 2 by 3 VCC, I have 1 by 3 VCC, my output, how the output will come according to the comparator. That is why I said that you understand first comparator, and then you can easily understand how the window detector works. So, when you apply V in below the lower voltage level, your which equates 1 by 3 VCC, the output will be low. When V in exceeds 1 by 3 VCC, the first op amp comparator detects this and switches the output high to VCC, right. That is why as soon as when the V in exceeds 1 by 3 VCC, you see here when V in is exceeding 1 by 3 VCC, the first op amp comparator detects, right, very easy, and switches the output high to VCC. As V in continues to increase, it passes the upper voltage reference 2 by 3 VCC. See, when it continues to increase, now it has passed this upper reference voltage 2 by 3 VCC. In this case, the second op amp comparator detects this and switches the output back to low. Why? Because if this is 2 by 3 VCC is less than the voltage which is at V in, their output will be high, output will be high, right. When you have this voltage which is here, let me just rub the other thing, so it is not confusing. When you have this voltage V in is less than 2 by 3 VCC, is less than 2 by 3 VCC, right, my output is high. When my V in is greater than 2 by 3 VCC, my output will be low, output would be low. That is what it says here, right. Same way here, what it was saying in here, what it was saying, when my input is less than 1 by 3 VCC, my output is low. When my input is greater than 1 by 3 VCC, slightly greater than V in, slightly greater than 1 by 3 VCC, then immediately this comparator will go as at 1, it go as 1 or high, go as 1 or high, right. This is what it is said here, that if you see here, once again, let us see here once again, see when V in is below lower voltage, right, which equates 1 by 3 VCC, output will be low. When V in exceeds 1 by 3 VCC, output suddenly the comparator detects and this switches the output to high. When V in continues to increase, when it increases below this above this, then the second op amp comparator detects this and switches back to the low. So, that means in this particular region, right, you see in this particular region you cannot see any output, or output is low. In this region which is greater than 1 by 3 VCC, the lower op amp was switched on. So, you have high. Here in this region again lower op amp is switched on. So, we have high. That means you can get the pulses, right, depending on the input signal that we apply, right, by using this particular configuration. Then the difference between the V reference upper and V reference lower, which is 2 by 3 VCC minus 1 by 3 VCC, creates the switching window for positive signal, for going to positive signal. What does that mean? That when you have this particular difference 2 by 3 VCC minus 1 by 3 VCC, then it will create a window which is the switching window for positive signal, right, because as soon as it goes between this particular value in this particular region, it will switch on, right. If it is less in this region, switch off, less in this region, switch off, only in this particular window it is switched on. That means, by changing this reference voltage we can create the different windows, we can create a switch on and switch off time. So, that is what is written here. Now, let us assume that V in is at maximum value, V in is at maximum value and equal to VCC, which is here, right. Then in this case, and as V in decreases, it passes the upper voltage reference of the second op amp comparator, which is the output high. That means that when V in goes back to low, suddenly the output becomes high, because the second op amp turns high. As V in continues to decrease, it passes the lower voltage level of the op amp again, and if it continues to decrease, then again it passes this particular level, and this will the op amp which was on, it will turn the output to 0, that means the V reference voltage. So, lower op amp, it will again switch the output to low. Thus, high and low creation by the op amps, 2 op amps, right, in this particular configuration helps us to create a window that we can detect. That window is created by the reference voltages of the upper reference and lower reference voltages. Now, the difference between V reference upper and V reference lower creates a window for negative going signal. So, we can see that V in passes above or passes below the upper and lower reference set by 2 op amp comparators. The output signal V out would be high or it will be low. You got it. So, now in this particular circuit, what we see is that when initially your input signal right is here, right, my output is 0, When this input signal reaches in this particular region, this op amp, right, slightly greater than this is input signal is slightly greater than 1 by 3 VCC, then this op amp will turn the output to 1. when this input voltage it increases to this in this region, when it goes to this particular region, right, then your V in becomes greater than 2 by 3 VCC, then my output would be 0, right. When you do again follow back, then you will again see this will switch to 1, because as soon as it becomes less than 2 by 3 VCC, then this you see is positive, right. So, this output becomes 1. If it is between 2 by 3 VCC and greater than 1 by 3 VCC, so as soon as it goes less than V reference voltage, means that this value is now less than 1 by 3 VCC. When it is less than 1 by 3 VCC, your inverting voltage is higher compared to non inverting, and output will become 0, right. That is how the switching occurs between high and low in the particular reference voltage in this region, and this is my window, that I can detect using this circuit. So, it is super easy circuit to understand if you understand how the comparator works. For understanding how the comparator works, you have to go back and see the video in which we were talking about the comparators, alright. So, let us see in this particular case, if I want to design a window detector. That means that how can I design window detector? So, here how you will know output is on or output is low or output is high. So, here what we have created is we have created a LED. That will give us the indication, right, of this window. So, what is that? Connect the circuit as shown in figure 2. Okay, we will connect the circuit like this. Here you can see the comparator 1, this is my comparator 1, this is my comparator 2, right. As you can see here, the reference voltage is given to my comparator 1 here, second reference voltage is given here, and then you have given signal. So, apply a DC input voltage from power supply, vary the input voltage as steps of 1 volt, and observe when 3 LED indicators red, light are on, right. That means that we keep on applying the step voltages from the input 1 volt, 2 volts, 3 volts, 4 volts, and what you have to see which LED will turn on and which LED will turn off, alright. So, to create this particular circuit, we will use two different ways. One is we will create using the breadboard, and another one we will create using the multisim, alright. So, you have the idea of both, how to design this comparator, using a breadboard, and how to design this comparator using a multisim. So, to perform this experiment, let us call Sitaram, who will join us to perform this particular experiment on the breadboard, and then he will join us on the multisim, so that I can tell you how the breadboard thing works, and while he is operating the multisim, I will again tell you how the multisim he is operating and how we can see the change in signals, alright. So, Sitaram, can you please come. So, now we have the breadboard. If you can focus on the breadboard, the circuit for the window detector is shown on the breadboard, Here also we have used red, yellow and green LED to indicate the output voltage. We can see here we have used resistors to form the reference voltages, right, and we have the 2 op amps. Here we have 2 op amps, right, 1 and 2, right, because we want to have 2 comparators. Now, you see you can also use the dual op amp in this case, but we are using the single op amp, because until now whatever experiments we have shown you is using a single op amp. Single op amp is your MUA 741. Alright. So, to perform this to operate this circuit, first thing we have to do is to apply the bias voltage. How we can apply the bias voltage? We have the DC power supply. So, you can see here in the DC power supply, now he has not connected the wires to the op amps. He will first connect the wires as a biasing voltage, and then he will start the power, alright. First he will connect it, then he will start the power. You can see. Okay, yeah. okay. And now we have applied plus VCC is plus minus 15 volts and minus 15 volts onto the op amp, that is the bias voltages, that is the bias voltages, plus 15 volts minus 15 volts with the help of DC power supply, with the help of DC power supply. Okay. Now what we will do, we will apply the input voltage in steps of 1 volt, right. So you can see he is now applying 1 volt with the help of DC power supply, and when he is applying 1 volt, what you are looking at? You are looking at the first LED is still on, second and third are not on, second and third is not on. Now he will subsequently increase the power, this first one LED is on, this yellow one is on, green and red is not on. Now he is going to increase the power, he is going to increase the voltage, sorry, at the input 2 volts, we cannot see any change, increase it to 3 volts, 4 volts, and then we are increasing to 5 volts, and so you see as soon as he reaches around 5 volts, we can see the change in the green LED. You can see here on the DC power supply it is 5 volts, right. Okay. So as soon as he will change it, so I can hold it, this circuit in my hand, so that you can also see the LED is glowing along with the voltage. So now reduce it back to 4 volts please. So you can see as soon as is less than 5, we can see the first LED glowing, right. So this is exactly, it is comparing the window between which it has to go high, Now if I increase the voltage from 5 to 6, 7, 8, and you see he is increasing slowly, right. I may be speaking very fast, but he is increasing extremely slow. This is how you have to slowly increase the voltage, alright. 9 volts, and then you can see 10 volts. As soon as it reaches 10 volts, you can see change in the LED. Now my red LED is on, you see 10, just about 10 volts my red LED is on. If I reduce back to 9, see 9.5, slowly can you increase with fine, 9.7, 9.8, 9.9, 10, and you can see green to red, right. See, and now you can decrease again from red to green, you look at the green, yes, see 0.1 volts, just 0.1 volts was difference, and suddenly the comparator switched its output, Now this is how we can see the comparator. If you go down now from 10.1 to 10 and 9.9, then you will suddenly see again the green color from red LED, the green LED is on, and if you go back to 5 volts, then you will see the red LED turning on, and the green LED would be, sorry, the yellow LED will be on and the green LED would be off. Yes, see, yellow LED is on and green LED is off. This is how you can guys form the window detector. It is detecting a window, right, for this particular circuit, and here we have demonstrated how you can use the LEDs to show the window detector, right. Excellent. Now let us see the similar application, using the multisim, and here we will see how you can design the circuit. That means he will take the operation amplifier, he will take the resistors, he will take the are you going to show LEDs there? Okay, he will use the LEDs from the library, and then he will apply voltage, and you will see that when you keep on applying the voltage from your 1 volt to your 5 volts to your 10 volts, you will see the change in the output. You will see the change in the output with respect to in terms of comparing. Comparing means when you increase slightly less than 5.1, your comparator will start changing the output, and you increase more than 10 voltage, again the comparator will change the output. So how to see that particular window of voltages in which we can see the change in the comparator output, we will see using the multisim. So, let us see the multisim. Can you focus on the screen please? Yeah. And now what we are going to do, we are designing the same circuit on the multisim. We are designing the same circuit on the multisim. Okay. So, now you guys can see, right, we have this multisim here, we can see multisim, he has opened it, and then now he is going to drag the one by one the circuit components that are required for designing the circuit, the components required. So, first he starts with the op amp. So, he has to select the op amp. So, he is selecting mu A 741, and then he has to, once he selects it, he can see, you can see here the op amp 741. Now, he requires 2 of this, right, he requires 2 of this. Again he is clicking on the terminals and then selecting 741. You can see now he has 2 741 op amps. Now, what we require? Now, we require resistors. So, we will select resistors, you can see, and you can select resistor, and then you have to place the resistor. You have the option of rotating the resistors, right, and you can option of changing the value of resistors. Here he is adjusting the resistors as per the circuit, right. So, in the circuit we have resistor of 100 ohms, so or 10 kilo ohms. So, he is using 10 kilo ohms, another resistors of 10 kilo ohm, and third resistors of 10 kilo ohm. All 3 resistors once he has done, then he will connect it. So, he will connect it, you can see, you can just drag it and you can connect the resistors, alright. Now, what is next thing? Next thing, he is going to select a ground, he select a ground and connect it below the R3, below the R3. Next thing is, he has to connect the inverting to the as 2 by 3 VCC, then another one 1 by 3 VCC, then we have input signal, which is again ground, because we are applying, oh, this is a power voltage, DC voltage that we are applying to the non inverting terminal, and we are connecting the another non inverting terminal of the operational amplifier with the same DC voltage. Right. So, he has applied 12 volts, as you can see from the figure also, same voltage. Now, what we are doing, we have to apply another DC voltage, which is your 15 volts. So, we can apply 15 volts. Right. Now, what we require? We require another 2 resistors. We require 2 resistors. So, he is selecting a resistor and one more resistor we require. The value of resistor is 1 kilo ohm, excellent. Now, we have to ground it. So, we have to drag it to the ground, connect the resistors, excellent. Now, what we have to do? We have to have LEDs, and you have LED, right. So, you have to connect in a reverse direction. So, see, there is a rotation feature. So, you can just select the LED and drag it, similar to what is shown here. Connect those LEDs, then connect the output of the second op amp and first op amp to the between the LED 1 and LED 2. Now, what we have to do? We have to connect the LEDs between resistor R4 and R5, right. So, we can just select both, drag it and connect it, right. This is done. Now, we have to select the this R6 and R7, For that, he is again had to select 2 resistors, which is selecting the resistors R6 and R7, and we have to connect the resistors. Values are 1 kilo ohm. You have to connect with a LED. Okay. Now, one side you have to ground it, So, we are selecting ground, another side you have to apply plus minus 15 volts. So, we are applying a DC voltage and we have to attach it, and another terminal we have to ground it. So, we have grounded it. Now, what we look at that we have to apply the bias voltage also, we have to apply change the DC voltage also, which is 15 volts minus 15 volts. Okay. Now, you have to name the LED. So, let us say our first LED should be red, second LED is green, and third LED is yellow. Okay. Now, you can also color it, you can see yellow. Okay. This one is yellow. Okay. Now, if I use ideal comparator, how can I see the change in the output? So, if you go back to the screen, what you are looking at right now is the same circuit considering the actual op amps. We are just taking ideal situation. Right now the input voltage is 0 volt. Now, you see that when your input voltage is 0 volt, right, that means that your U2 right, this reference voltage is about 5 volts, is about 5 volts because it will be 1 by 3 of 15 volts, this is 5 volts. So, now if I start increasing the voltage, if I right now my input voltage is 5 millivolts, 10 millivolts, you can see that there is. So, if you see the yellow LED is on because the positive terminal is higher than the negative terminal, that is the anode is higher at voltage compared to the cathode, because the output is right now at 0 volt. You can see 0 at pin number 7 or blue. Now, he is increasing the voltage, he is increasing the voltage to 2, 3, 4, and as soon as he increase more than 5, suddenly see there is a change. Now, what you can see now your LED, green LED is on, because you have your non-inverting terminal at a higher potential compared to the inverting terminal in operational amplifier 2, op amp 2 or comparator 2. Thus, you can see LED is on. Now, he is going to increase it further, and when we see on increasing it to about 10 volts, suddenly you see LED 1, that is your red LED is on, right. Same way, if I you see the voltage is also, you can measure the voltage across the LED at the cathode of the LED, we have 4.31 volts, at the anode it is 5 volts, that is why the anode is a higher potential compared to cathode, and that is why we are LED is our LED 1 is on. And then when we decrease it, again, you will see that as soon as we go less than 10 volts, then we have the yellow LED on, because the non-inverting terminal of the U1 is at higher potential compared to the non-inverting terminal. And then why it is higher potential, because the non-inverting terminal we have 8.55 volts, inverting terminal we have 10 volts, that is why inverting terminal is higher compared to non-inverting terminal, and that is why your output voltage would be 0, because it is a comparator, right, it is a comparator. That is why your LED anode, LED 2, your cathode will be at 0 volt and anode is at 5 volts, that is why LED 2 will start glowing, right. Same way, if you keep on decreasing and it is less than 5 volts, you will see that your LED is 3 is on, it was already on, LED 2 and LED 1 will not work. This is how you can find the detection or the window voltages when you set the reference voltages. So, here we can set the reference voltage, upper reference and lower reference. Upper reference will be about 10 volts, lower reference is about 5 volts, you can see it, right, and this is how you can do the simulation, and it kind of matches what we have understood in the theory. So, that is why it's good to learn. I do not say that multisim or any other tool of simulation you should not use, you should definitely use it, right, definitely use it, but just do not rely on simulation. Every time you just rely on simulation and assuming that it will work in the experiment, it may not work, in that case you should not really come out with the things that, oh, I did simulation, experimental it is not working, or experimental is working, simulation not working. You have to try and figure it out, right, try each circuit, open it, close it, right, what you will see, you will not get the output. If you do not get the output, you ask us, right. I have designed this circuit, I have integrated this circuit, we cannot see the output, what should be possible problem? First you have to find it out, if you do not get it then you can ask, alright. So, here what we have seen one more application of operational amplifier, and that is a window detector, window detector. Now, we will see the next application of operational amplifier in the next module. So, at a stretch, if you see this module you will understand that we have used op amps, two op amps as a comparator, and then we have used reference voltages with upper reference voltage and lower reference voltage, and then we have seen how these op amps as a comparator when connected in a particular format can be used to detect the peak voltages, alright. So, with this we will finish this module, and I will see you in the next module. Till then you take care, bye.